A quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. In our question, we are given that root 2 is the sum of the zeros and 1 by 3 is the product of the zeros. And based on this given information, we need to construct a quadratic polynomial. Again, let's revise the concept first. So the concept which we'll be using is that for any given polynomial ax square plus bx plus c, the sum of the zeros, that is alpha plus beta, is given by minus b by a, and the product of the zeros alpha beta is given by c by a. So based on this formula, we will be finding the solution of this question. So let's see how to solve it. We know that sum of the roots alpha plus beta is minus b by a, and in our question it's given that root 2 is nothing but sum of the roots. That means alpha plus beta is root 2. Let's substitute it here. So root 2 is equal to minus b by a. And similarly, product of the roots alpha beta is given by c by a. In our question, product of the roots is nothing but 1 by 3. That is 1 by 3 is nothing but alpha into beta. So 1 by 3 is equal to c by a. Now we have two equations. Again, just for convenience, I'll try to make both the denominators same. So because the denominator here is 3, I'll try to make the denominator of this equation also as 3. How do I do that? I'll just multiply and divide the denominator and numerator by 3. So root 2 into 3 by 3 is equal to minus b by a. That is nothing but 3 root 2 by 3 is equal to minus b by a. So now I have two equations. 3 root 2 by 3 is equal to minus b by a and 1 by 3 is equal to c by a. Based on this, I need to construct one quadratic polynomial. As you know, based on this given information, you can get infinitely many quadratic polynomials. Suppose if I take a is equal to 1, you get different b and c value. If I take a is equal to 2, you get different b and c value. Like that, you can get infinitely many different solutions. But because in our question, they just asked us to construct just one quadratic polynomial, we'll do that by taking some good value of a. See, because both the denominators are 3, which I made it for the convenience of easy calculations. So because both the denominators are 3, I'll try taking a is equal to 3. Now, here, if a is equal to 3, directly minus b is equal to 3 root 2. That means b is equal to minus 3 root 2. Okay, again, let me repeat. If a is equal to 3, minus b is equal to 3 root 2. That means b is equal to minus 3 root 2. That's what I wrote here. Now, let's come over here. If a is equal to 3, then c is directly equal to 1. So, c directly will be equal to 1. So, again, you know, this is the general form of quadratic polynomial, ax square plus bx plus c. Now, we have values of a, b and c. Let's substitute these values to get the quadratic polynomial. So, it will be 3x square because a is equal to 3. Now, b is equal to minus 3 root 2. So, it's minus 3 root 2x. C is equal to 1. So, it's plus 1. So, this is the quadratic polynomial based on the given information, that is sum of the roots is root 2 and product of the roots is 1 by 3. So, our one quadratic polynomial is 3x square minus 3 root 2x plus 1. Again, let me repeat, this is just one solution. You can have infinitely many solutions and all those are correct. So, even if you take a is equal to 1, the examiner won't tell you it's wrong. Any solution is correct. Just for the sake of convenience, we took a is equal to 3. I hope this is very clear. In case you still have any doubts in this question, please let me know. Thank you.